Hello and welcome to another episode of On.NET Live. I'm your host, Myra Wenzel, with my co-host, Cam Soper and Cecil Phillip. And I would like to welcome today's guest, Daniel Nakolah. Daniel, can you introduce yourself?
Hello, everyone. My name is Daniel Nakolah. I'm a .NET developer here in Kenya. I'm mostly a backend developer, and I love to play around with technology. So yeah, that's why I'm here today, to show you one of my toys.
Awesome. And today we're going to be talking about optimizing.
That's all for me.
Okay. And today we're going to be talking about optimizing data operations with CQRS and minimal APIs. Sounds very interesting. All right. Do we have a banner, Cam, or are we just jumping right into the subject now?
Oh yeah, we have the. Do we ever decide? Are we going to keep running this?
I don't know.
So
bumper? I'm gonna run the bumper. So we have. So we've been experimenting with changing the format lately, and we have bumpers for each segment, and we got rid of the segments, so we're not sure what to do with the bumpers anymore. So I'm gonna run this bumper. This might be the last time we see this bumper, so bid farewell to it. It's been a good bumper. We respect its service and its contribution to our stream.
But
All right.
I must say that the transition in the beginning was flawless. Like it was perfect. All right, Daniel, enough of chit chat. We would like to give you the floor to present what you prepared today for us.
Yeah. So uh, I prepared for us just I don't like slides honestly, so I just we're going to get our hands dirty and we're going to start playing around with these things. So that's how I tend to learn new technologies. If I want to know what is this, I just go to the quickest documentation near me, then I just play around with it. So I'm going to take you through my my understanding of this technology. So minimal APIs in its essence is just a way that .NET stripped down everything in their controllers and just gave you the bare minimum so that you can build everything you want from it. So the genius of it is that you don't need to have an understanding of the way what do you need to inherit, what do you need to call, where do I need to put this piece of code so that I can put my controllers, blah blah blah, and all those things. So all you just need to do is just open your program file. So for instance, here in this program file, we can delete all these things. So yeah, this is the startup file for your .NET application, for your web API application, that is. And if we want to hit the ground running and start developing, it's crazy easy. I probably hate myself for coding on a live show. Anything can go wrong. So results, that's okay. So yeah, it's just that fast for me to build an endpoint. Very easy. So if I run this and I call it, this is the endpoint I'll get. So let me just open my terminal. Yeah, let me just zoom it in so that we can all see. If I go to that directory,
You have some Oh My Posh there too, which is really cool. I cannot use the terminal without it anymore.
yeah.
So I actually turn off
So
Oh My
there's
Posh.
also this.
Oh, sorry, Daniel. I didn't mean to cut you off. We've got a little bit of latency, I think, in the transmission. I was just going to comment on Oh My Posh. I actually turn it off a little bit when I'm recording screen recordings, and now I miss it like so much when I turn it off. But I don't want to like throw people off when I show them the screen recordings and they they don't know what it is. It really hurts when I don't have it.
So okay, the beauty with Rider, you can just run your endpoints here. So let me just open in editor. So if I just run the endpoint, this endpoint, okay, I think yeah, it has the wrong. There's this binding I found in terminal. It was really interesting, where you just press control space or any other key binding you want, and then your terminal just drops down. It's brilliant. So, let me run it again. Yeah. So okay.
Hey Daniel, would you mind making that font size just a little bit bigger, because I can't see what's in that window right now.
All right.
Yeah,
okay. Well,
that's
better.
good.
Thank you.
I think he froze.
I think he's stuck. I mean, his
To
mouse
get
is over.
the gist of it is that
Oh, he's back. Daniel, we lost
the
you
gist
for
of
a
it is that
second. So
okay. So am I back? Am I back on?
yes.
Are we together again? All right. So just yeah. So the gist of these minimal APIs is that they're so simple to build, and you will design them the way you want to. So one thing that I should mention is that I love cooking. So my example here was just recipes. Yeah, if we go back to where we were before the purge. Yeah, I just created some simple endpoints. I created some simple endpoints for recipes, and I used just an in memory. So if we walk through this solution that I've done, this is just an in memory. Let me zoom in. This is just a list of recipes that I created in memory, and as I have a recipe service that I'm calling from my endpoints. So the structure of the minimal APIs is just you call it directly from the application, from the web application. So this is the pattern of the template, and then the handler is just a function. So I actually love the way functions are implemented, because when you're moving between languages like TypeScript and C#, you'll find a lot of similarity to this. Then it's not like it just makes it way much easier for developers to move between languages. So here I'm using, this is not actually necessary in my case. I don't need to include from services, but I just like to be very descriptive what I'm doing. Now I'm saying that this is just dependency injection. I'm saying it's coming from the services, from the registered it as a singleton. So resolve it from the dependency tree. So that's it. When I'll come get my recipes and return my recipes. This is just a basic CRUD operations with the same. So how does this compare to controllers? Because we've worked with controllers before. This is what has been there throughout. So this is the traditional controller doing the same exact thing as 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 we were doing with minimal APIs. I added a logging service for something I was logging. I can't remember. So it does the same exact thing. It's just a one-on-one with the minimal APIs. But as you can see, we don't really for the controllers we need to add other configurations. For instance, we need to add the controllers in the services, and then we also need to map them in the web application. It's easy to miss one or the other. Very easy. I've missed it a lot of times, trust me. And you go in a spiral asking yourself, well, what's going on with my application? Why did I get it wrong? So that's a gist of minimal APIs, where you can just create your endpoints very fast with minimal code. It doesn't mean it's easy. It's not the easier thing to do, but it's actually I find that it's the first thing that I run to when I need to prototype something fast, and I need to build something to test it if it works. I've created a service, or I've created a service that I need to test if it works from an endpoint, if it's registered correctly, if the scope is okay and all. I just create a minimal endpoint, and it does the job for me. But that should not be the only thing that we do with it, because it's actually really, really powerful. With minimal APIs, you can do multiple things. You can group them the way you just group your controllers. You can create you can group them to like the recipes controllers. They're together. You can group if you have now the ingredients, group them together. This just creates everything is now bundled together. The beauty with this is that if we come back to our first example, this when I'm working with controllers and I need to change these endpoints, For instance, let's say now I need to get the recipes that I want viewed. So maybe I need to add a new from the service. I need to change something, and if we go to the service, I change that. Let's say now we need to get recipes specific that have a prep time of less than 20 minutes. So I'll come to my recipe service. Let's create a new method, and then it says public recipe get recipes. With cook, I like the recipe with cook time under 20 minutes. So yeah, and then we just return. Let's let AI help us. So if we come back, to this endpoint, we create another endpoint. Here comes my main problem with controllers. Okay, one of my problems with controllers is that if I need to add a new endpoint, or I need to add a new, or to change one endpoint, the whole file is affected. And now this file was considered closed before I started making these changes. Now something that is totally doesn't need to open this file. Now I need to add a new change. Now it breaks the open close principle. So if we now do this HTTP get for recipes 20 minutes or less time. So we return this. Let's return these recipes.
Yeah, it looks like there's a lot more plumbing that you have to do to get everything wired up with the controller.
Exactly. So if now this is if we return this, we've just done exactly what we've returned these recipes, but as you can see, we need to change. Now we have already let's say dirtied this controller, and we need not do that. So if it was just for if we're doing it in the minimal API, we'll just create a new endpoint. And forgive me for this, but these endpoints. Ideally, you'd create a new endpoints folder, and then you'll group them together. And each endpoint you can now. There's no need to put them all in the program. The program file to create a program file hell. You'll have a program file with 1,000 lines. Now you have to go. You scroll down to get something. So it's not completely ideal. So once you group them into their own folder, you just change what you need to change. And since the controllers, the way the dependencies are resolved, when you call an endpoint, this dependency will still be resolved by the scope of an endpoint. There's absolutely no reason to group them together. So if that's why my main let me just jump into an idea that I was just toying around with. I think it has been implemented in multiple other. If you've played with the Adalis architecture for Adalis view on clean architecture, you'd see that it's grouped his points per an endpoint has its own file. So one endpoint its own file, and then you can you do the dependency injection per endpoint, and you just inject everything you want and in that specific endpoint. So let's now go to the next part of the talk, which is now the CQRS, the command query responsibility segregation. So as the name says, it's just that we need to separate our commands. Our commands are basically our posts, our puts, or our patches, basically the mutations we do to our data. We separate them from our queries so that we might have additional logic for our commands. We might want to do audits that this specific user did this at this specific time. When he was doing this, we might do some extra validations on command. We might decide to use a different type of a different data store. Now, for instance, our commands, we might send them directly to our SQL server, and then for our queries, we send them to we fetch them from cache. Let's say we have a Redis server that we've cached our entities. So this is where we can pull them, and then we pull them from that. So if you separate your concerns, your commands and your queries, and they act separately, this now it makes your application more robust in the sense that it's easier for any person who's working on that project to know where everything lies, and just everything is just way much cleaner. So let me just minimize all these.
And then while you're doing that, Daniel, I did have a question I wanted to ask you. So
Yeah.
So I'm not a CQRS familiar person. Like, what are some use cases that I should consider using? I don't know, clean architecture and CQRS and some of these types of things. Like, can I just put them in every application, or are there particular scenarios that you think it makes sense for me to use something like this?
So everything in technology, it depends. So yeah,
I was waiting for it.
You shouldn't. It's like microservices and monoliths. There's an advantage and disadvantage to everything. This CQRS is actually very it has a lot of bloat. So you have to set up a lot of things. There's a lot of configurations you have to do, which is not necessary if you're building an application with 5 endpoints. For instance, the recipe app that I had just shown before. If now I implement that in CQRS for, let's say, my own project, now I just spend a lot of time doing configurations, which is totally not necessary. So the idea is just do what you need to get the job done. Once the project gets big enough, now you can now think about the best way to architect it. If you're building something small to play around with, or to just a microservice with 5 endpoints, there's no need to create a whole 5 projects just to handle those 3 endpoints. Doesn't make sense. So for big projects,
so you'd say that CQRS it would be for more complex projects that have more endpoints and more in that nature of complexity.
Exactly. Larger projects, you need to do more architecting on them. Otherwise, they'll be unmanageable. So let me just show you what I was playing with here. So for here, it's the same thing we were doing before. We have our recipes. We have our recipes, and we have our CRUD operations. So here, I was playing around with Mediator, the library that we use to send our requests, and they have handlers. So the way Mediator is architected is that, and this actually flows in the CQRS pattern. CQRS basically is when you've separated your concerns, you have different layers of your application. So if I have my endpoints communicate with handlers. So they say, Mediator, give me a list of the recipes that I need. So Mediator knows that this recipe request has a request handler that I need to resolve and get the recipes based on that handler. So, and Mediator is so beautiful and powerful because you can do almost everything you can do with endpoints with it. So you can do the normal CRUD operations with the iRequest and iRequest handler interfaces. You can do event streaming. For instance, the way ChatGPT is now very, very common. If you're playing around with its endpoints and you need to stream the data from the ChatGPT endpoint via your web API to your client, you can do that streaming to that using Mediator. Now, if you have notifications you need to send to your user, Mediator version 12, there was a complaint with Mediator that the notifications are sequential. So when I pile up my notifications and I queue them, it's one by one that will be sent. So that can create a performance bottleneck. But with version 12, there is a way you can now send them in parallel, and so they cover that bottleneck. It's quite impressive. But you'll see. Yes, I think about last week I was just stuck when I was migrating. I was testing out version 12 because there was a change they did. I didn't notice it. So it was a breaking change they had implemented. I didn't notice it, so I was just caught in a loop trying to figure out. If I read the documentation, it would have saved me hours. So this is just if you ignore these, I grouped my command. These are command in the command, and this is the command handler. So the command, I use just a record so that I can have it inline and create it directly there. So from in this command, I created I did some reflection and things so that it can behave as an endpoint. So this is just I added the HTTP post with the recipes endpoint, and from body attribute to say that this DTO comes from the body, yeah. And this I create request is basically an interface wrapping the iRequest interface, so that I can be able to separate my interfaces. So if we come to contracts and interface and mappings, and Mediator, you can see that I have I delete. I just created them this way so that I can be able to separate them when I'm building the app. So it's just a wrapper around the iRequest and the iRequest handler. Nothing fancy. And these ones come from Mediator. So this is the request that I send to Mediator. So when in these, this is just the way you build you build your normal requests and request handlers in Mediator. So this is now my handler, and the way this system actually functions, I just did some mappings with. I did some mappings with using reflection where I'm able to identify which parts from the assembly to identify the methods. And now, for instance, in this create recipe, I'd get this HTTP post method, and then I get this attribute, and then I get the attribute belongs to this class, and this class has this request, blah blah blah. So once this now in this okay, you can just have a look at the code base. I'll share a link to the repository where you can have a look at how this was implemented. So
just a basic question, since I'm not familiar with Mediator. So Mediator is a package that you use that encapsulates the CQRS logic. Is that what it is?
Yes. I was getting to that. So Mediator, yes, it's a package where you add you install it from NuGet, and then you register it. So in this case now, when I'm registering it in the services, it scans your assembly for the specific interfaces, like for the iRequest interface and the corresponding handlers, and now it registers them. So now that's it scans, and then now, for instance, here when it says add open behavior, it's basically this is a middleware. Behaviors are they're just middlewares where now it's between the request and the request handler. When it's being resolved, now you can do validations. You can time how long it takes for the handler to return, and yeah. So if we go to a validation behavior, it's just you implement it using the iPipeline behavior, and now this next is basically the request handler delegate that wraps around the request handler. So this is what is run. This is what is run to resolve the handler, basically. So
and in this case, are you using like connecting to a SQL database or?
So I'm just using for this demo. I'm just using an in-memory database. But
this one as well. Okay.
yeah, I have a DB context, a very simple DB context with just the recipe, and then yeah, you have the DB set, and it has an interface that wraps around it. Now the interface is what I am actually injecting in my handlers. So if I added some razzle dazzle for mapping. So if now I'm mapping my recipes to the DTO, you should as a rule of thumb, you shouldn't expose your entity types to your endpoints. They need they're separate things. So I needed to wrap them in I created a mapper to do the same. When I'm creating them, I map. And if we look at our create DTO, if these required attributes are just basically for, these required attributes are basically to show to show to tell the.
Are you using AutoMapper or some other mapping package to do the mapping between the DTO and the other objects?
I'm using AutoMapper.
Okay.
So I created an interface for the create DTO. Just so in this base, in this base DTO we have the mapping a mapping method, which now this mapping method what we're just saying is that when in a DTO, for instance, this recipe create DTO, this is where we create we create our mapping. So I'm just grouping everything together. The recipe and its mapping, the DTO and its mapping are in one file, like they're in one class. So I have a mapping profile that just uses some reflection to create the mapping profile for the whole application. Now, when you register your automapper in the program, in program, you just say you add it, and then it'll scan to get all the types, to get all the mappings in the program.
Okay.
And in terms of the step-by-step of what you did to get to this point where you have everything configured, I don't know if you could walk us through like what you did first so that we can get an idea of the sequence.
Yeah. So as I said, these if I come to my command and I remove, I think I know why this was failing. It was pointing to a different file down that I'm in right now. So let me just open these in my browser. So I configured Swagger in these as well. So So in my when I'm creating this mediator extension, let me just show you in this mediate method, I configured I added these attributes so that when I'm adding the Swagger package here, I can when I'm adding these Swagger packages, I can be able to it can be able to notice to pick up these metadata. So when I'm getting my recipes, let's just try it out. So when I'm getting my recipes, it returns an empty because the in-memory database is empty. So let's just create a quick recipe. Let's just copy the one that we had in the first. Let's do a chicken tikka masala. I love this one. So the description masala. This will take 20 minutes. So it has created the chicken. It has created that recipe. Then, if we pull, we've added it into an in-memory database. So this is. Let me now walk you through what made this possible, because it's like I'm doing magic now, and I hate magic. So when you're creating an endpoint, for this, when you're creating let's say you're creating a map get endpoint for hello, just the one that we had done previously. So this just returns the hello world from in our browser. But then something that was introduced I think in .NET 7, if I'm not wrong, is that you can group, you can create a record here for our hello. So let's just call it our hello request. Our hello request has a string for, let's say, world, and we have another string for name. Let's say, person name. Sorry. Public. So if we now want to pass this into our to get these as, we want to pass this here and get it from, let's say, our body. We can say from body, and then we pass it. You've seen they have just done in the other one. So from body, and then you put your request and you get it. But then I want to group my request, this hello request, together with a goodbye request. So if we just, let's just do the same. We want to group this together and pass them. One we're getting it from the, both of them are getting it. One we're getting from the body, the other one we're getting from, let's say, from the query string. So what we can do is we can create now like a wrapper request, and then this wrapper request, we have our public hello request, and we have a goodbye request. So Copilot is amazing. So if want to create our wrapper request, and then we can add now attributes to say that this one we're getting it from the body. This one we're getting it from the query. Yeah. So then here, what we'll come and do, we'll just come and say that there's a new attribute as parameters, and then we say the wrapper request. So this wrapper attribute, this is what powers my the whole how I came to create these endpoints. And from my endpoints, like I was able to create them in the specific requests and request handlers, and then I use reflection to and use the specific attributes that I had created here. If in my command, now these ones are resolved as parameters. If we come to our mediate method so here we just have these we are familiar with this. This is it's just like a map get, but then it's a parent. We can call it like the parent method, extension method for this. Now you pass in the method specific HTTP method for that, and then from services, now we just inject mediator, and then as parameters, it's the type of request. And in our case, the type of request is this is the type of request.
So what it looks like for me from what you've shown us so far is that like mediator is a good way to kind of decouple the processing of the requests with the thing that actually does the processing. So, you know, you have your API endpoint, right? And you have, I don't know, some routes and some methods, and, you know, it's going to respond to a thing, but then, you know, you create some messages or some requests and response types. You pass it over to mediator. Now mediator is doing it somewhere else, but the code is not there, right? So I think for me, it makes it a little bit cleaner because now I don't have like a super big, you know what I mean, API endpoint with a bunch of stuff in it. But then two, yeah. I'd love for you to talk, maybe if you can, a little bit about, have you found that this has made it a little bit more testable, maybe? Like, you know, because now like your logic and your API handling mechanism is two different places. Like, how has that changed the way that you look at testing, you know, these endpoints?
Yeah. So when I'm testing my endpoints, I just need to test the logic of the endpoint. So if I'm doing a unit test, I create a test case. I'll create the test case for this specific handler. I mock the handler, and now you just do the normal mocking where you have your interfaces, you mock your interfaces. It just makes it so much cleaner to do testing, in that there's just a specific part of the code you're testing. I'm testing this endpoint. I already know the dependencies I need. I don't need to. If you go back to our controllers, you can if you have a whole controller, my specific endpoint might not be using any of this, like one of the services up there that I've injected. But in this case, this specific handler for my endpoint has all the services that I'm using. So it just makes it more explicit when I'm doing my testing, what I need to test and exactly what I'm testing.
And from what I was seeing, the CQRS, instead of using basic crude operations, you're kind of separating the reading from the update. So it's like you can use the messaging and everything for like handling concurrent requests and things like that. Is that why on a complex system you would consider using this architecture?
Yeah, so if now I'm adding a new recipe in my case, and I have a distributed cache, and I need to update the cache with the new changes. I need to invalidate the cache per se. So I can have in my commands, I can have additional events that will be able to now to do this in my commands. That is, once this recipe is created, we have events that are dispatched to handle such things. So as you just said, it just in big applications where you have different needs for different parts of the application. When you separate your commands with your queries, it just makes building them way much easier in the grand scale that is of the systems.
Okay.
So yeah. Are there any questions that have been raised?
Yeah, I have a question when it comes to, so when you look at like the acronym CQRS, right? I think it's command query,
Yeah,
request separation or segregation, or I know what S stands for. It stands for something. I think about, okay, well, there's the command and then there's the query, right? Like I'm guessing the command is like, I'm going to ask you to do a thing, right? And then the query is me getting the thing back, right? And so the separation is that like my command entryway. Oh, there you go. Thank you. Appreciate it. My command entryway and my query entryway are like, they're separate, right? So again, the segregation part of it, right? Like they're separate endpoints. How do you think about that? I mean, I know we're sharing a demo here with like an in-memory database. How do you think about that when it comes to like the database that it's going to? Like, do you like, I know I've seen some people, again, I'm not an expert. I've seen some people do it with like different databases. So like the database that you read from and the database that you write from is not the same for scaling reasons or security reasons or whatever the case is. You know what I mean? Like what are some, I don't know, recommendations or patterns that you see people use when they're, when they want to keep their write side or their command side and the query side separate?
So the way you just separated the from in your handlers, you've separated them. Your handlers, your requests and your handlers they're already separated into the commands and the queries per se. So if you have a different database where you want to store, now you want to persist your commands, for instance, now from that, now you have jobs that propagate the new changes and synchronize between your microservices and that. So in such a case, if I'm building, let's say in this, I've expounded my application I've expanded my application to have now, let's say, recipe generation, recipe ingredients. I can monitor my fridge. I can be able to see all those things. Now I come home with shopping, and I need to add those shoppings. Now that's a command. Now I'm adding to my pantry. So with that, I don't want to create. I have a job that this is a theoretical job that from my fridge, I can be able to create recipes, to generate recipes automatically. Let's say I've integrated with the GPT-4, GPT-3, whatever, and I create recipes based on the ingredient list that I have. When I create a command, when I'm adding, let's say, sugar, I'm adding soy sauce, washer sauce. So when I'm adding all those things, this propagates to a specific database that I've decided. I have the master database, and in this master database, everything has to resolve to that master database. So it has to be in sync with that master database. So as it propagates the changes to the other databases, there's one single point of truth. So that's how people might decide to, different engineers might decide to approach it. I want to have one single source of truth for my system. So I decide to go to CQRS so that I can have, when I'm putting all my commands, will go to one source of.
Okay.
Yeah.
Yeah, Philip just had a question. Isn't this just store procedures and views rebranded? And I'm from that era that you use SQL Server and store procedures and queries and views to connect to your database.
No. I've used stored procedures, and I've developed with just let's say just the normal entity framework and all, without using with business logic, that is. And business logic is just, it's way more testable, it's way cleaner, anybody can understand, even somebody who just got into the system. Yeah. So
And then Dave is asking, like, so how do you make the written data available for reading in the other database? So how do you keep them in sync?
okay, so these now that's a database that's a database question. So I can say if I'm building a recipe, as I said, if I'm adding a recipe, and we can create a domain event where when I add a recipe, there's a domain event that is thrown. Let's say, yeah, it's emitted that a new recipe has been created, and this is the recipe. So if I have let's say several microservices, and they can listen to this event that will be, we will have a message queue, and then we can push these messages into that message queue, and then from that message queue, you can now synchronize your databases. You just have a background service that gets the new messages and resolves them and saves and make sure that every microservice database is in sync. So that's one way to approach it. Many other ways you can do it.
Yeah, I think that also just depends on. So yeah, I agree with what Daniel was saying. I think it also depends on the database that you use, right? Because like this is a fairly database agnostic conversation. So it could be Cosmos or SQL Server, or it could be, I don't know, whatever, MongoDB, whatever database you want to use, right? And so I think depending on the database, you might want to have like a different replication strategy and a different, this is the right database, this is the read database, and the networking and all those types of things. But I think more so what's important is like the pattern, right? And to understand like how the pattern lays on top of said technology, right? And so the understanding is that, again, like we have a command entryway, right? And then there's a query entryway. And now these are connecting to different things, you know what I mean? For scalability reasons, for auditing reasons, for security, for whatever your use case might be. The implementation detail is just, that's dependent on whatever database your company decides that they want to run.
Yeah.
Awesome. I think that's all the questions that we had up until this point. I don't know if you have anything that you'd like to show us in terms of running the application, or
okay, I just I think this slipped my mind. You can, as I've shown you the middlewares for this specific endpoint, when you're building these services. So when I added this behavior, this validation behavior, each request you can attach a validator to it. I'm using Fluent validation here. So you can attach a validator to it and then validate between the request and the request handler. So here I just done a simple validation for my recipe. So you have to have a required name, you have to blah blah blah, description and cook time, and you can have even more complex ones. For instance, when you're deleting your recipe, the provided ID has to exist. So you can have a dependent rule for that specific. For instance, you say like the ID should not be default, or it is a GUID, so it can't be an empty GUID or null. So then that's when you can have these. You can have these to now. You can now check in the database to make sure that it exists. So yeah. And you might say that this might cost now. We are doing a double round trip to the database to just find a recipe. That's why I'm using find async now. What find async just basically does is that, as it can say, it first of all checks in the context. If it's not in the context, then it goes to the database, And then once it ships from the database, it puts it in context and then returns it. So when I'm coming to my recipe command and I use the same, I find async again, it will check in the context. Now this time it will be in the context. So it's cached in the context. So there's a caching layer on the context. So there's no round trip to the database. So yeah, you can add different behaviors, as I'd said, to this. And in your commands, you can decide now to have additional validation on them to make sure now you can add now validations on authorization to make sure the right people are accessing these. There's now rate limiting and stuff. So you might decide you can go crazy with the power that minimal API gives you. So yeah, that's I've come to the end of my rambling.
It's great. We're almost up to the hour, so use your time well. So thank you so much, Daniel, for coming and sharing your knowledge with us. And I think that's what the show is about, is like just highlighting the community and its members and us sharing knowledge and learning from each other. So thank you for stepping up to come to the show. We really appreciate it. And next week we're gonna have Garrett London that is gonna be talking about API governance with Donna Core and Postman Enterprise. So tune in. We're gonna be scheduling the show soon. And if you want to be on the show as well, like Daniel here, you can go to this address, aka.ms/onnetlive-guest, and submit your show. I think we have a few spots in the upcoming months for you to come here. And with that, I really, really want to thank Daniel for coming here and for everyone for tuning in to the show. So thank you so much.